All right, let's check this question together. Another projectile question, a projectile motion question, a fairground game. Requires the player to catapult a ball towards the target to score points. The ball is required to reach the target at a horizontal distance of 50 meter away, the same vertical height, at the same vertical height, and the time taken is given to us here. So this is 50 meters. Okay, this is the S horizontal, the horizontal distance, and this is the time. This is the time. The time also is given to us. It is 2 here. All right, now we want to get the angle which is over here. This is our target now. Okay, we know that this is the horizontal component of U, and this is the vertical component of U. All right, let's take it step by step. The first thing that we have to do is to start with the vertical and horizontal, and let's put them inside a table as we usually do. This is the SUVAT, all right, and now let's take it step by step. The first thing that we need to know is, now let's plug in the numbers that we have first. 50 is the horizontal distance, so let's put the 50 here. The time for the whole journey is 2. The time to reach to go from this point to that point is 2. So we're gonna put 2 here and 2 there. And this is something that is always shared. The time is shared always between the horizontal and the vertical component. All right, now one other thing is, we know that if you want to get the velocity here, U or V is the same. Why is that? Because going in the horizontal direction means that there is no air resistance. No air resistance, so this means that we're going with a constant velocity. So the velocity in the beginning is the same as the velocity in the end. If you want to get any one of these two velocities, so you can simply use the easiest equation for velocity. Velocity equals distance or displacement over time. All right, why did he use this? Because actually we do not have the final velocity and initial velocity. Both of them are the same actually. This equation, this simple equation can be used only in the horizontal motion. Why? Because actually as long as we are having a constant velocity, we just said that there is no v and u, these two are going to be the same, and the acceleration here is going to be always 0. Acceleration is 0 because we're going with a constant velocity. So as long as you have an acceleration of 0, so you can simply use this method. Now, the distance is given to us as 50. You're going to put the 50 here. Now, the time is 2. We're going to put the time here. Now, we're going to get the velocity in this direction or this dimension. This is going to be 25 meters second to the power of -1. So we're going to put the 25 here. You're going to put the 25 there as well. Now we have solved everything in the horizontal component. The next thing that we need to do is to find the u here. Yes, this one over here. This vertical component, we need to get it. So for you to do this, let's think about it a little bit. Now, we have the time to do the whole journey. The time for the whole journey, we have it. So what about the time to reach this point? The time to reach this point is going to be half of it. Let's say that this is t half, which is to reach the maximum height in the vertical dimension. So this is the t. Let's say that the t half is going to be 1 in this case, isn't it? All right. Now, this is going to be 1, and at this point, the velocity, the final velocity is going to be 0. So let's put the final velocity here as 0. And as long as we're going up, which means against the acceleration of free fall that takes us down, U is positive, so acceleration of free fall has to be negative. So you're gonna put minus 9.81 here. All right. Now we can simply get this U. How are you going to get this U? The thing that we don't have is S. So what is the equation of Suvat? Which kinematic equation can we use? You're going to use V equals U plus AT. All right, this is very good. Let's move forward a little bit. This V here is given to us as 0. The U is the thing that we want to get, and minus 9.81 times the time here, the time to reach the maximum height, which is 1. So this means that you're going to get this 9.8 to the other side. This minus here is going to be positive on the other side, so U equals 9.81. 9.81 is the initial velocity. Now, as long as we have the vertical component and the horizontal component, can't we go ahead and get this U now? Or get this angle? The angle is the thing that we need to get now. So can't we get the angle now? This is going to be easy. How's that? Simply, you're going to draw the components. This is the angle over here, which is theta. The horizontal component is 25. The vertical component is 9.81. Okay, so now we want to get this angle. All right, let me change the colors. So this one is adjacent to the angle. This one is opposite to the angle. So O and A, this means they're going to use 2A. So this means they're going to use tan of the angle. Tan of the angle, all right, equals what? Equals 9.81 divided by 25. Now, this means that theta equals tan minus 1. 9.81 divided by 25, which is going to be 21.4. 21.4 is the angle. That's it. Thank you so much. I hope you enjoyed this video. See you later.